Good morning, everyone, and welcome to the Arizona Lithium Investor Webinar. I'm Jade Morgan, the Investor and Media Relations Manager, and today we are joined by Managing Director Paul Lloyd and Technical Director Brett Ray. Today's webinar will be a company update, including an overview of the resource upgrade announcement, which was lodged on the ASX yesterday, followed by a Q&A session. So to ask a question throughout today's webinar, please use the Q&A function, which can be found at the bottom of your screen. Paul, I'll hand over to you.
Thanks, Jane, and good morning, investors and shareholders, and welcome again to the Lithium Research Centre. I've got a number of issues to discuss, and I'd like to move through fairly quickly because you can see that Brett has his lab coat on and he wants to do another demonstration that everyone seemed to enjoy last time. So I'll discuss the capital raise that we just did more recently, the Big Sandy project, the BLM, NTEC, the Lithium Research Centre, Prairie, and our NASDAQ listing. So the capital raise that we did recently, we raised $10 million through sophisticated investors, and that has given us the ability now to finalise the PFS on the Prairie project and the DFS on the Big Sandy. So we're well funded now to continue with fast-tracking these two excellent development projects in North America, and we're in a good financial position. So let's talk about the Big Sandy project. It is our #1 project. I was the vendor a long time ago now of that project, and we're very passionate about that project. That's why we have the Lithium Research Centre. That's why we're building a pilot plant. And yes, we are delayed with our BLM approvals to do additional drilling. But if we look at what we've got out there at Big Sandy, it's only 2 hours north of where I'm standing right at the moment. We're in Arizona. They've hit a record temperature of 50 degrees over the last few weeks, and I can tell you it's as hot as hell here. So the people know that climate change is happening, and they know that the economy has to change. So when I talk to federal ministers and senators, they understand the issues there, and we are the only project in this state that has a JORC compliant resource, that only over 4% of our land holding, and we can build that very quickly once we do have drilling approvals. We have done an aerial survey recently at the Big Sandy project, and that was to assist with the topography, a very technical type thing, but we are advancing that project. I'm looking forward to starting the baseline environmental studies, and NTEC, our commercial partner on that project, is assisting greatly there. They will be doing the permitting and they will be doing the contract mining when that project goes into production. I've got a lot of correspondence from shareholders more recently about the drilling approvals, and I can tell you, don't worry, but this state we're operating in is a very mining friendly state, and other companies have had delays before, so they've got over. We do have a 12-year mine life out at the Big Sandy project, which is quite significant, and we'll expand that to something like 50 years when we do additional drilling. So we have also produced battery-grade lithium from ore from the Big Sandy project, and it's good to know that from your project you can produce a high-quality product, and the leaching that we've done previously and that Brett is now working on has excellent results there. So it's a great project. We just need to get over this hump of drilling, and then we're away. But we're still very focused on the Big Sandy project. The management team is working hard at the processing side of it, and we'll be back drilling there in the near future. So the pilot plant for the Big Sandy project is pretty much half of the Lithium Research Centre. You see in the background the world-class lab. So on the other side of that brick wall will be a massive pilot plant, and that will assist with the Big Sandy project. So if anyone has any concerns about us devoted to the Big Sandy project, send me an email. But remembering I am the original vendor, and I do love that project. So to address the BLM issue, we have provided all the information to the Bureau of Land Management. We have an excellent relationship with the BLM, and NTEC are helping out significantly with that relationship. We haven't had any further questions in regards to what we're doing out there. The previous drilling that we did, we rehabilitated to a very, very high standard, and we are very well respected within the BLM. They are the company that they are the entity that is making the decision on the drilling. I can push them along, and we are doing that, and all our management team are focused on obtaining that drilling approvals. There's not too many hours go by where I don't think about that drilling approval. So we are 100% focused on that, and I'm 100% sure we will obtain that. What timeline? I'm not sure. I did give a timeline previously, and I'm not planning to do that in the future. But just to understand what we're doing here is that the BLM are the landowners. We have a lease from the Bureau of Land Management. They make the final decisions. So they have to engage stakeholders. And one of those is obviously the person that owns the lease, in this case, Arizona Lithium, and we have satisfied all the requirements that the BLM have provided to us. So I can talk all about the low environmental impact of the Big Sandy project and all the boxes that it ticks for ESG. But at the end of the day, the Bureau of Land Management need to make that decision, and I am sure that they will be making it from a positive point of view for our company. I'm just not sure of the timeline at this present time. To talk about NTEC. NTEC is a very good strategic partner for us. That's the Navajo Nation mining arm. And just to put in context, they mine 50 million tonnes of coal in this country, and they are one of the largest coal producers in this country. They are pivoting to the new economy, and they are, and that is part of AZL partnership with NTEC. They are providing a lot of assistance with the Bureau of Land Management and liaison. They're opening a lot of political doors for us, and I couldn't be happier with NTEC. So anyone who's thinking that they've gone quiet, that is not the case. They're a great partner. They'll help with funding, they'll help with permitting and government liaison. Brett has worked previously with the NTEC people, and they really are world class. Let's just talk quickly about the LRC. We came up with that terminology, the Lithium Research Centre. It's effectively a world-class lab and a pilot plant for Big Sandy. And that pilot plant is progressing, but as you can see in the background, we have the lab up and running. That lab is providing us with a commercial advantage, and I think that we will see some other investments in other lithium projects potentially, because we do have this Lithium Research Centre. So I'm very happy with the decision of the board to spend the money on the Lithium Research Centre. Prairie. We came out recently with, which was yesterday, or actually yesterday for us, but time zones, we put that announcement together on Sunday, and we're talking now about a 39% increase in the resource at the Prairie project. It's only north of the US border into Canada, and there is a lot of infrastructure up there. So a brine project that has a indicated resource of 4 million tonnes of LCE, when the market for that product is worldwide is only 720,000 tonnes at present, but growing quickly, granted, that is a huge world-class project. And we're looking forward to advancing that project with the cooperation of the provincial government, because it is an oil and gas producing region. It has all the infrastructure, and we're not doing anything different to what the oil and gas companies are doing. We are developing up the DLE technology that we acquired as part of the Prairie project, but most importantly, we are putting a pilot plant into the field in November, and those results will be very exciting and will show the value of that project. We'll finish off the PFS on Prairie in December, and now that we have such a large resource in indicated, I'm expecting those financial numbers to be very robust. So that is very comparable to Lake. So if you want to look at Lake, some of these investors on the call would know Lake very well. They're down in Argentina. we are in Canada, virtually no political risk and infrastructure everywhere in an oil and gas region. So the market cap of Lake, I think, is about $300 million, and we will be in production much quicker than Lake. I expect production from the Prairie project to be within the next 18 to 24 months, and that will be on a modular basis. We see that there will be a strategic or a structural change in the industry, and that will be direct lithium extraction brine projects. So your directors have made a decision to enter that space at exactly the right time. And as we see that market change over the next 12 months, as projects go into commercial production, I see that the value will increase massively of all those projects. And I think shareholders will be rewarded very well for the advanced and strategic nature of the board that we have at AZL. In regards to that, it follows through to our NASDAQ listing. Matt Blumberg, who's based in New York, is doing a very good job pushing the NASDAQ listing along. We have the lawyers and accountants doing all their work, and we are ready to go as soon as the market comes back. The US market goes into a little bit of recess in their summer, and as soon as the traders and the dealers are all back, we'll be listing on the NASDAQ. So that's a quick summary, and I'll hand over to Brett, and he will tell you a little bit more from a technical point of view what he's doing at the LRC.
Sure. Yeah, let's go ahead and talk about the LRC progress now. So Jane, you want to show some of those? Just got some photos of where our construction is. Actually, we'll show those at the end. So this is the back of our facility. Again, this is about a 20,000 square foot facility. We're standing in about 4,000 square feet of it right now, which is a laboratory. This is the back of the facility where a lot of our equipment, in particular the filter press, requires large amounts of compressed air. So we've just got our compressed air system with our dryer there. And we're also beginning to build the tank farm in back that's going to have a lot of the brine that we bring in from various places around the world to process it, in particular through DLE, which we'll talk a little bit later. And here, this is actually the wall right behind us. A lot of the penetrations there in the wall go to the equipment right behind me here. But this is our sample prep area. So this is, in particular for Big Sandy, we bring in rocks from the field, samples from the field, core samples, and we have to go through size reduction steps. And then, of course, we have to split weigh. We generate lots of samples from our bench studies we're doing, so we have drawing. And the other thing we do too is we do use a LIBS gun that will give us really accuracy within about 10% we're seeing on lithium, instantaneous. We use that in the field. And here recently now, we can use it on brine. So technology is really starting to catch up to where you can get lithium numbers very quickly, both out in the field and a chemical plant, as well as pilot plant. So we're using all of that technology here as well. And here's just another area. This is a good portion of a warehouse is where we secure all of our core samples. We have to secure those behind lock and fence. So this, as you can see here, about 4 levels of our core samples. Then we also, all the lithium products we make, lithium carbonate, lithium hydroxide, things that we bring into the facility, we really have to lock that up. There's probably about $30,000 of lithium back there right now. So that's just one section of the warehouse back there. And this is where we're beginning to assemble our equipment, primarily for the front part of Big Sandy. So we've got the attrition scrubber there. We actually built that ourselves. It's our proprietary design. It's a 4-compartment scrubber that we use with these pilot plants. We like to use gravity as much as possible versus pumping. It's a 4-compartment scrubber. We've got tip speeds of about 1,000 feet per minute in each of those compartments. And when I talk about the samples behind me, it'll become more obvious why we have to do that. We've got screening and thickening equipment. We've got leach circuit and neutralization circuit that we're putting together. And we expect kind of the centerpiece, the filter press, which is a 1.5 meter by 1.5 meter plate, about 8 of those plates, that will ship to us the end of September. So we're anxious to get that. Once we get that, we are effectively fully functional for the LRC in terms of processing ore from Big Sandy. Is that it? Okay, here's an example. Now this is very kind of a sister to the one that we're going to have. That has more filter press plates. We'll only have about 8 due to the size of our feed charges. We'll process ore in 1,000-kilogram lots. But our press is a little bit bigger than that plate-wise, but we'll have 8 of those plates, and it's 2 stories. So you're seeing kind of stairs and upper mezzanine. Ours will also be a 2-story filter press. And the reason we did this is that there's a lot of scale-up issues involved with filtering, especially when you go to wash the cake in the filter press to remove the lithium residue that you certainly don't want to throw away. And we've actually developed our own plate that flushes the filter cake with huge amounts of water so that we do not have to use a CCD circuit or something like that to try and rinse all the lithium from the filter cake. And so we'll kind of go through that a little bit with the samples behind me. Okay, that's it. Okay, I'm going to move to the table behind me here, and we're just going to go through some samples, and I'll talk about the latest development here in the space. Looking well here. Okay, so this is for everybody to see. I'm gonna go through.
Actually, Brett, you might just need to move that one just back towards the rest of them.
There you go. Okay.
Yeah.
Okay. All right. Reorganize everything here. So I'm showing some similarities. Yes, Big Sandy and Prairie Lithium are, one's a brine and one's a sedimentary clay, but they are actually quite similar. In fact, almost identical once you get to certain parts of the flow sheet. So when we're doing work on Prairie Lithium, in particular with direct lithium extraction and crystallization, this is all work that also is used for Big Sandy. So they are not exclusive of one another. In fact, while we do work on either, we're actually at the same time developing the other resource. So I'm just going to go through some steps here. I went through a little bit of this in the last demo, but this is just a quick summary. So this is really our run of mine ore. We know from our test work, as well as the work I did previously with AgriPass, that the lithium is in the fines. So the first thing we do is we add water in a nutrition scrubber, and that's the nutrition scrubber that we built ourselves, that just high velocity agitators break all the particles up. And what that does is it allows us to use just conventional screening. And this material right here, this is coarse material, has virtually no lithium in it. Just through a screening process and a classification process, this is discarded. This is coarse gangue. I'm just going to set it there because we're not completely done with it yet. This is a dried out version. We don't dry it and filter it commercial scale. I just did it for demonstration purposes. This is our actual ore where all the lithium is. So all we've done at this point in our flow sheet, we've added water, we've classified it, we've discarded coarse material that doesn't have lithium, and now we have this fine material. We add, at this stage, we're basing the design off using sulfuric acid. However, there are alternatives to sulfuric acid that are showing promise to us that are significantly less money than building a $300 million sulfuric acid plant. So we're pursuing that work here at the research center. I can't talk much about it now, but as we develop the technology, certainly there'll be press releases and stuff like that as we get going, but I really can't talk much about those alternatives right now. They also do involve a partner that we're working with, so we've got disclosure rules there as well. But something very important we're working on are the alternatives to sulfuric acid. So here's our ore. We add sulfuric acid. The portion of the ore that does not dissolve is our tailing. And then we, of course, after we add that acid, we bring the pH up with lime and we produce a filter cake. Now, this is why we have the filter press at the LRC. We'll make filter cakes that are about 5 times thicker than this. But this is really exactly what it looks like. And what we will do is we take this material that's been fully neutralized, we blend it with the coarse material right here, and this material will get backfilled right in the excavation created by mining. So not only do we not leave a hole in the ground, we don't leave a pit lake. In fact, we create a little bit more volume than what we took out of the ground. And so not only is there an indentation in the ground for where we once mined, very likely it's going to be a little bit of mound we get to contour into, so it blends into the surrounding area. So again, we don't have a pit. We don't have pit lakes. We fill in the hole, and these are the tailings we produce. Now, this is where the flow sheets really become quite similar, almost identical. So in Big Sandy, this is the lithium sulfate brine that we create at Big Sandy by using sulfuric acid to dissolve the lithium from the rock and then filtering it. This over here on this side of the table, I think you can see, I'm going to move all this stuff back and out of the way. So here is brine produced by Big Sandy. This is brine coming out of the ground from Prairie Lithium. At this stage, we're very similar. The brine coming out of the ground at Prairie Lithium is about 150 ppm. The brine from Big Sandy, though, is about 2,000 or 3,000 ppm lithium. However, DLE is the most efficient way of rejecting these impurities. And many people think this is new and untested technology. In fact, DLE has been used to reject impurities for at least 2 years now by some of the largest, well, the largest lithium company, one of the largest lithium companies in the world in China. This is not a new application of DLE to reject impurities. So we will also use it, and we'll test it here, but we would like to use it at Big Sandy to reject impurities without going through crystallization and adding a bunch of reagents to produce magnesium hydroxide. So again, the brine from Big Sandy, the brine from Prairie Lithium. Now one's a sulfate, one's a chloride. DLE doesn't care with the technology that we use. So with Prairie Lithium, now we get into that flow sheet. So after we go with DLE, we produce, again, another water clear sample, 1,000 ppm solution of lithium chloride, which is right here. We then go through a step, which is the conventional. You're going to see a lot of flow sheets. There are some projects that are in construction right now. Many of them after DLE use a membrane step, a CFRO step. Think of it as using reverse osmosis to remove water and concentrate lithium. So that is the next step in the Prairie Lithium flow sheet, as will be the next step in the Big Sandy flow sheet. So we're kind of the same steps here, although one's a sulfate, one's a chloride brine. Some differences in the equipment, but effectively still the same. So once we get through that membrane step, we make a concentrate that is loaded with lithium. Now this is 20,000 ppm lithium right here. This is right out of a laboratory test that we've done with a partner we're using to help develop the PFS right now. Because of DLE, we've rejected almost all the impurities. We have sodium and lithium in here. That's it, and 20,000 ppm lithium and about 20,000 ppm sodium. But still, a very pure feedstock to crystallize, produce lithium salt. Here's the other stream. It's a permeate. It's basically water. This is, we could actually put a little work into this, and this could be water used for irrigation. When we get to use RO, we get a lot of benefits like that. Now, the last step is once we get that 20,000 ppm lithium, we simply add heat, just like we've done in our lab here today. And this is very high purity lithium chloride. So this is what we will make, and a lot of people, a lot of projects now are beginning to look at production of this midstream product, which is very easy to make, and then do the conversion, do the purification in a conversion plant elsewhere. But what a lot of people don't talk about is the advantage with using DLE is that we've rejected an enormous amount of impurities that are not rejected with spodumene or other techniques. One of the reasons why we want to use DLE at Big Sandy is that it is so efficient at rejecting the impurities. Virtually all we have to do is remove water, and we have a very pure sample of lithium chloride. In the case of Big Sandy, it'll be a sample of lithium sulfate. Now, that lithium sulfate, because the impurities have been removed, can get converted to lithium carbonate or lithium hydroxide very, very easily. It's not like converting spodumene or another ore where you've just loaded with impurities and you have a very difficult time controlling the concentration of those impurities. DLE kind of levels everything out. We go through the RO steps that really smooth everything out. And then the nice thing with the salt is that you can make any lithium concentration you want to begin the crystallization process. You're just adding water, in particular cold water, to get all this material dissolved. So this is, first time maybe you've seen it, this is very high purity lithium chloride. That the only way we made that is we took this concentrate right here and we removed heat from it, or we added heat to it and boiled off the water, recovered the water into very pure condensate. Again, it'd actually be cleaned up and used for irrigation or recycled, which we'll do in the process. But here's our finished product. That's a chloride at lithium or at Big Sandy. It'll be lithium sulfate. So see, yes, the beginning of the flow sheet is different, but when we get to about the middle of it, and after we put the lithium in solution, because of DLE, things kind of, they're really the same. So any developments we make for Prairie Lithium are also developments that we can use for Big Sandy. And just quick in closing, talking about DLE, we all know that Exxon has entered the picture now. They are the largest resource and energy company that is in the lithium space, $500 billion of market cap. And Exxon could have done spodumene. They could have done anything they wanted to, but they chose brine, and the project that they have selected requires the use of DLE. So that goes to tell you right there, we've been working on DLE. I mean, I go back to my career working on DLE for over 10 years. We're making it. We're getting really, really close. You're starting to see all the signs. You've got one of the largest companies in the world is entering the space with a project that is 100% reliant on DLE. We've got a project in the US that's in the ground right now in Utah that is using DLE to remove impurities. The Chinese have had those projects operating for a year or two. Now the Chinese don't feel compelled to talk about their successes with DLE. I guess why would they? But we're catching up in the US. We'll have DLE too. We're doing our pilot test, the largest pilot test that we can do in November. Now, we've already done very small scale tests, both with third party and with our own technology, and this stuff works. We're just finalizing some details, getting some costs down, and really determining on how we want to make that midstream product and then how we want to convert it. So we're really excited about this, and it's one of the reasons why we can get Prairie going much more quickly. I mean, we're not building a multi-billion-dollar chemical plant like a lot of projects are when we talk about extracting DLE from brine that's pumped from a well. We'll construct these plants in clusters or to feed for brine that is fed from a cluster of wells. And maybe each cluster makes maybe 4 or 5 tons per day of LCE. But we will have those clusters in wells all over the oil field. So, there's certainly an advantage with this design that Exxon saw. Of course, Exxon also saw the advantage that with these brine projects, you don't have to spend any energy to get it into a liquid form from a solid form. Mother Nature has already done that for you. All you have to do is remove the impurities and remove the water. So, of course, they've seen that. There's excellent infrastructure in all of these areas. At Prairie Lithium, where we're at, there's oil and gas infrastructure all around us. Power, roads, very skilled labor, a very important one. It's all over the area. I mean, it's been the Bakken and the Williston Basin area is full of very highly skilled contractors and drillers. So really the advantages for DLE are starting to pile up. The biggest risk to date has been the technology itself. And you're starting to see people enter the space that are not known for necessarily taking big risk. And so that's really, it's an indication that things are going to start to turn. And where we're at in Prairie, with arguably one of the best brine resources in North America, we're right in the middle of it right now. And Exxon was the first big oil and gas company to come in the space. They certainly aren't going to be in last. So I think you'll see these brine resources. You're going to see DLE technology in the next 6 months, 9 months, really begin to make an impact here. And the nice thing with us is being that we've got a sedimentary project, everything that we're learning and developing for DLE for Prairie, we're going to use at Big Sandy. It's just going to be a sulfate brine versus a chloride brine, but we're making sure that everything we do works for both. So that's really in short what we're doing here at the Research Center, what we'll continue to do. And where we think we're going with DLE, just a couple of other things. Our crystallizer is on order. Not sure when it's going to ship yet, but this will allow us to produce the finished products right here at the Research Center. And we'll also have, not only do we have our own DLE technology here, which is a different technology than what we're currently testing. We've actually tested our own homegrown DLE technology, and we've tested a completely different DLE technology. And in each case, we're recovering over 90% of the lithium. So we're working on both of those technologies here, and we'll make a decision before obviously we construct the Prairie Lithium project as to which of those technologies that we'll use. And we very easily might use both of them. There isn't anything that says that we can't use one DLE technology for one cluster of wells and our own DLE technology for another cluster. That's the advantage of DLE, is you're not making a decision that impacts $1 billion chemical plant. There could be another DLE technology that comes up 3 years from now that's better than either of those, and we just remove it and put in a new one, or we just drill new wells with using that new technology. So I'm really a big proponent of DLE. Of course, I've been in it for about 10 years, and we've figured out a way to implement it at Big Sandy, and we're very excited about that right now. That's it, Jane, for me.
Brilliant. We might actually head to some questions. Questions now. Again, webinar attendees, please use the Q&A function, which can be found at the bottom of your screen. But let me jump into them. So one for you, Brett. So if you substitute the sulfuric acid step with another form to reject some impurities, does this materially change the next few steps of refinement?
No, because all we're looking at is effectively that point is water removal. Now, sulfuric acid is very non-selective. So as you can imagine, the alternative to sulfuric acid we're looking at, not only is it less expensive than sulfuric acid, which is actually difficult to do. When you make your own sulfuric acid, you can do it very competitively. But one of the main things we're looking for in alternative is having it be more selective for the lithium and not dissolve so much magnesium and potassium and things like that. So we've actually got some good results in that regard that we should be able to share some of those, probably not this year, but next year when we get it more developed for commercial scale.
Wonderful. Another one for you, Brett. So what percentage of LCE is produced at the last stage of the flow sheet?
Produced at the last stage of the flow sheet, we don't really produce any there. We convert it. So at the last stage, we're taking 20,000 ppm lithium, and we're effectively removing all of the water and making a very almost, it's technical grade lithium chloride. So, at that point, that product then gets converted into battery grade lithium carbonate, lithium hydroxide, or both. Same with lithium sulfate. So we don't lose any lithium in that step really at all. All the lithium that we lose to a loss and recovery at Big Sandy is lithium that is not leached when we add the lixiviant, or it was lithium that was in the coarse size fraction in that coarse rock that we just could not attrit, and it stayed in a big grain, and that's really where the main lithium losses are. But once we get into DLE, we're over 92% recovery, and we recycle a lot of those losses, in fact. And then in the RO step, any lithium that isn't recovered into the concentrate, all of that gets recycled back into the process. So there really is very little lithium loss once you get through DLE.
Thanks, Brett. Another one. So how does the DLE increase lithium production?
Well, again, it doesn't. You only produce as much lithium as you want to either drill, pump from the ground, or mine. So with DLE, there's a ratio of however many module needs for how many cubic meters per hour you want to pump onto the ground, which is a function of how many wells. So yes, you could do 100,000 tons per year of DLE of lithium if you wanted to, but it's going to take 100 wells or more. It's going to take a lot of wells, which are numbers that, from an oil and gas perspective, 100 wells. I mean, that's nothing. So we can scale these things. Now we're going to start out small in small clusters. We're probably looking at somewhere around 5 or 6 wells. We'll cluster those wells to produce DLE at a central location. But it's a trade-off between piping and other infrastructure things. So it looks like we're probably looking at about 5 or 6 wells per DLE plant. But that'll change with the resource.
But if you compare a DLE project using, a brine project using DLE or evaporative ponds, the recovery rate is basically double. So for the evaporative ponds, the historic brine projects run it in the 40s as a percentage recovery of the lithium. And then as DLE technology improves and goes into commercial production, you're talking in the 90s. So there's a massive difference there.
Yeah, and I think with DLE too, just to add, DLE is compatible with solar evaporation too. It's not one or the other. DLE is excellent at rejecting impurities, and a lot of the impurities in brine and the solar evaporation are responsible for the loss and recovery, especially potassium. So you're going to begin to see, as we prove lithium out in our project, a DLE out in our project, you're going to see DLE applied in some new ways, because again, it's one heck of a technology to reduce impurities that could form double salts and cause you to lose lithium in a pond.
Thank you, gentlemen. So next one, a few months ago, AZL substantially reduced its presence in Canada. Are you now in the process of rebuilding it for your November pilot plant? And if so, what sort of skills and people are you bringing on?
What we did once we completed the acquisition of Prairie, we looked at our staff across the board, and we saw some synergies that were available. So we did reduce our headcount somewhat in Canada, but all for the benefit of both projects going forward. So as we go to the drilling phase next year, we'll have to increase our headcount again there. But there are, as Brett mentioned, a lot of skills available in Saskatchewan and Alberta for drilling. And but at the moment, we were just trying to maximise, or in fact minimise the outlay of cash while we're in this study period, for the benefit of shareholders.
Thank you, Paul. So this is just a little bit more of a statement, but so if the Prairie resource is 5.7 million tonnes and the current price of LCE is 42,000, so this is a huge number in terms of NPV. And so even if a 90% discount is assumed for analysis, this still means US $7 per share value just from Prairie. I think this user is just sort of asking, why isn't the market really understanding this?
I suppose it goes back to developing up the Big Sandy project, in that no one knew about sedimentary, about sedimentary projects. Now we have Thacker Pass kicking goals at construction phase, and people are now looking at the sedimentary space. I think DLE is the same. So Prairie fits into that DLE space. Once you start to see companies commercialising their DLE projects, the valuation will go through the roof.
Thank you, Paul. We're jumping around a little bit here, but so would you consider reducing the number of drill sites to expedite the BLM approvals?
That's not sort of an issue that's going to help with the BLM being approved. So we know the number of holes we need to drill, and we mostly wouldn't go and drill all those holes straight away. But any adjustment to the number of holes is not an issue at all.
Wonderful. So next one, you mentioned that the Prairie PFS will be completed in approximately December. Will that document be filed publicly?
Yes, it will be. Yes, that will be an ASX announcement and completed to a standard where we can announce that. So we do have a large indicated resource now of 4 million tonnes of LCE.
Okay, and so do you anticipate having to utilize workforce housing camps for any of the projects in Canada or the US?
Brett, do you want to answer?
No, I mean, that's the beautiful thing with DLE. I mean, these are very small footprint projects that are out in the oil and gas fields. Not to mention, I mean, there's just a phenomenal number of highly skilled contractors in the oil and gas patch. So not at all in Prairie. And even in Big Sandy, I mean, we're awfully close to Kingman. You know, we're just not man camp, you know, kind of locations. There's lots of skilled folks here in the Phoenix area that service the copper mines. I really don't see any need for a man cap in the Wickiup area with just Kingman and in Wickenburg and a lot of, you know, it's the drive from a lot of these places to the mine site is a lot less what a lot of folks do every day in the Nevada area, in the Elko area, going to their mines. So I don't see really a need for a big man camp or anything like that. We're just not that rural in our locations, lucky enough.
Thank you, gentlemen. So does the DLE method chosen depend on the flow sheet using either chloride stream material from Prairie or sulfate stream from Big Sandy?
So with both DLE technologies that we are using, and one of the reasons why we've selected them, they work with chloride and sulfate. The recoveries are the same. So in fact, our own technology that we've developed may have appears to be having a slightly higher absorption density for a sulfate than a chloride. So again, we're early stages in we're getting the manufacturing process down of our own DLE material, but you know, there are some third-party DLE out there that have really been working and improving their DLE for the better part of 10 years. So there are some folks out there that have a significant jump on us in development, not only manufacturing, but on just understanding how it works. And we would just be foolish to not look at technologies from third parties that have been developing their technology for 10 years, where, you know, we're on about year 2. So we're catching up, but there are some excellent technologies out there. And I can't give any details, but if anybody really researches the type of technologies for DLE that appear to be winning, you're going to see a pattern. And we are obviously, we know what this pattern is. We're using technology in this pattern, but there are some winners that are beginning to emerge. And you'll see this more and more over the next 6 to 9 months with projects that are getting built and projects that are already operating in China.
Thanks, Brett. So, and is it correct to assume that first production and sales are aimed at approximately Q1, Q2 of 2025?
Yes, that's correct.
Yeah, best case scenario, yes.
Wonderful. Okay. So how easy are the brines from Prairie and Big Sandy to refine compared to Thacker Pass? And also, are you seeing that the refining process will be cheaper to that of Thacker Pass?
Sure. So it's not so much as a function of the quality of the resource, it's the technology that we use. So when you use DLE, you are rejecting, you know, to a very high degree, some of the impurities, you're rejecting 99% of them. When you reject impurities to that extent, it doesn't matter if you're a sedimentary clay, a brine, or even if you've roasted a spodumene ore, and you're looking for a way to remove impurities before you go into crystallization. So it's really the DLE is the critical thing here. It's just such a good rejector of impurities. It can take even the most troubling ores, whether it be a sedimentary clay or a brine, and it can make them make very good products or feedstocks going into a carbonate or hydroxide plant.
Thank you, gentlemen. This question's got 3 parts. So what is the scale of the pilot project in terms of tons per year? And how long do you see the pilot running before full commercialization and scale up? And finally, so what will the size be per module in tons per year?
Sure. So I think maybe I'll start with Big Sandy first in that regard. So with Big Sandy, we've already, Hazen in our scoping study has already demonstrated the flow sheet. They've already produced lithium carbonate. We know exactly how to do it. With the pilot plant, we want to process ore in 1,000 kilogram lots to really kind of look at the variation and make sure that we get the design of the plant such that there is enough flexibility to see typical fluctuations in lithium and some of the impurities. And because lithium is associated kind of in a size fraction and not just pure concentration, it's a little more challenging to do that just by looking at a core sample. We actually need the bulk ore in order to do that work. So for Big Sandy, we'll process in 1,000 kilogram lots, and we'll kind of accumulate the lithium sulfate from those lots into larger batches, and then we'll run them through our large crystallizer that can crystallize 1,000 gallons of concentrated lithium sulfate in 24 hours. So once we get it, we'll produce quite significant quantities, certainly for testing and for our customers, potential customers to look at. In terms of Prairie, we've already done the nice thing with DLE, just so many advantages with it, is that the scale up concept with DLE, it's different. I mean, you're not talking about a vessel that is sized for hundreds of cubic meters an hour. Our pilot plant that we use, that we're going to use in Saskatchewan, is only does a few gallons per minute, but even a full size doesn't do but maybe 10 or 20 times more than that. The difference is we just multiply those modules. So scale up is quite manageable, quite different in DLE because you increase your production by just adding more modules, not by making giant pieces of process equipment like you do when you think about 40,000 LCE per year crystallizer or lithium hydroxide plant. So yeah, we'll run about 500,000 gallons of brine, and that is our third party that is managing the facility is more than comfortable with as long as we run steady state at 2 or 3 weeks. They're more than comfortable at using that to design and construct a plant. And in fact, we're not the first people to do this and design and construct a plant from it. There's somebody in the ground right now. Actually, there are a couple in the ground, especially the ones in China. So scale up for me on DLE is the last thing that I worry about in DLE is scale up. I worry more about scale up doing very large crystallizers for lithium hydroxide in particular. But DLE, a column that is an inch in diameter versus a column that is 8 inches in diameter, 10 inches diameter, I'm not too concerned.
Wonderful, gentlemen. I think that's covered all of the questions for today. And I want to thank everybody for joining us for the Arizona Lithium Investor webinar. A copy of today's recording will be available online in the coming days, but if we've missed any questions, please feel free to reach out by the contact details on the bottom of our ASX releases. Brett and Paul, thank you again.
Thank you.
Thanks, Jane. Thanks, everyone.